Good everyone, my name is Graphics. Today we want to study thermodynamics. It's also an aspect of physics, right? But we call applied physics. Now, if you look at the word thermo means energy, or we can call it heat. Then the word dynamics means energy in what? In motion. So how we know very well from our basic education that energy can neither be created nor destroyed, but can be transformed from one form to another. So what thermodynamics is interested in is how this energy is being transformed from one form to another. As this energy is being transformed, the useful work that is being done, right? So there are some things we need to be conversant with, some things we need to know, our basic understanding. So I will call them the terminologies used in this topic. First of all, what is thermodynamics? We say that thermodynamics is the study of what? Energy, the transformation of energy from one form to another, and in relation to different states of matter, right? So, for we to be able to analyze energy or understand energy, we need to study energy and how this energy is being transformed from one form to another. Like we know we have what is called, for instance, now let's take the instance of a generator. That is the conversion of what? Chemical energy into mechanical energy, from mechanical energy into what? Into electrical energy. So this is how the energy is being moved from one form to another, right? And how it relates to the velocity of matter. We know matter is anything that has mass and can occupy space, and we have different states of matter: solid, liquid, and gas. The liquid and the gas are called fluid because of what? They flow. Now, what are the terminologies that we are going to be using here? Some of the terminology we'll be conversant with is what we call a system. We have what? System. A system is the quantity of matter enclosed in a boundary for thermodynamic study. Now, the quantity of matter, like now, the two keywords here is what we call a boundary, right? Boundary. Now, the boundary on its own is what separates the system from the surrounding. For instance, now let's take a good example of one system that we know about. We something we call the blood system or the circulatory system. Circulatory system. What are we circulating? Sometimes we can be circulating the blood, right? The blood circulates, and so on and so forth. So what we are considering actually there is what? Is the system. Now, in terms of your refrigeration, the system there is your refrigerant, right? The refrigerant is what moves round the what? The system, right? From the compressor to the condenser, from the condenser to the expander, from the expander to the evaporator. Now, what is moving there? What is making the fridge to be cold in the evaporator? It is how the system, which is the refrigerant, transports the heat away by lowering the temperature. So the system is what? The quantity of matter enclosed in a boundary for what? Thermodynamic study. For thermodynamic studies, right? So what I want us to look at now is what we call the boundary. That means the boundary separates the system from where? The surrounding. Let's take for instance, if you have your pure water in your sachet, what are we protecting? We are protecting the water in the sachet. What is stopping the water from spilling? The sachet itself, right? So that sachet, to a layman, is what we call what? The boundary. While the water in the sachet is called what? The system, right? But anything external to it is called what? The surrounding. Now, if I give a good illustration of this, like if I have something like this, what is inside it is what? The system. What is separating the system from it is called what? The boundary. Right? and anything external to the boundary is called what? The surrounding. So the surrounding is what? Anything external to what? The system. Are we good? Now we have different kind of system, right? Different kind of system. One of the system we have, we call it an open system. An open system. We know that the open system is a system that only allows the flow of energy across the boundary. It's a type of system that allows what? The flow of energy across the boundary. So, it allows the flow of what? Energy and mass across the boundary. Now, if I take an illustration, now let's take instance your pot of water on your stove, right? When you place your pot of water on your stove, now, and you did not close the pot, then the pot heats up. As the pot heats up, what happens? The water in the pot absorbs the heat. Is that taken? Now, the water is hot, boiling. Now, if I off the stove, what do you notice? With time, the water cools off. But one thing you need to take note of is that if you place your hand on top, above the surface of the water, you see some vapor, right? Wet gas coming out from it. If you place your hand there or on top of it, you see that your hand will be covered with what? The vapor of the water in form of what? The steam. Now, the water on your skin is what? Is the mass, right? While the temperature, since it's high, is hot, is what? The heat. So the heat is escaping with the vapor. So when the heat is escaping with the vapor, you call such a system an open system. What I mean is this: if I have this, assume this is what? This is my pot here, and it is open. This is the water in. Now there are some steam that will be escaping in form of what? Vapor. Now, since heat plus what? Some minute content of water is escaping, let me call it vapor, right? You say such a system is what? An open system, because the flow of what? Energy, which is the heat, and mass, which is the vapor, across the boundary that allows the flow, right? And mind you, this body of the pot here is also called the boundary because it's protecting the water, it's stopping the water from spilling. Also, heat also will escape from the boundary, because if you touch the surface of your pot, as in the surface of the pot, you see that it is hot, so heat is escaping. So this is a lame explanation of what? Of an open system. So example of open system is what? Is a turbine. One example of an open system is called what? A turbine. Another example is what? Water flowing in a pump, right? Because, and another one again is piston cylinder combination with what? Open valve. So these are the three we have. If you look at this piston cylinder combination with open valve, you're talking about a 4-stroke engine. You see that in the inlet stroke, air will come in, mixture of air and gas will come in. When it's combust, at the end product will be what? The burnt air. That is the exhaust gas, which is the burnt air. So and so on and so forth. So another example types of system is what we call the closed system. Number 2, we have what is called the closed system. If you look at the closed system, it is just the opposite of what? The open system, right? So if the open system allows the flow of energy and mass, now I want you to answer this for yourself. If I have a heated water in a pot, right? If I have a heated water in a pot this way, heated water in a pot this way, and the pot is what? Is closed, is sealed, is closed. Let me put it that way. Now I'm no longer heating it, but it is hot. With time, what will happen to the water without heating? it will start cooling down. What happened is that heat is escaping from the boundary, just only heat, but the vapor remain intact because it is closed. So a system that allows only the flow of heat, the heat is called the energy, across the boundary is said to be what? An open system. So open system allows the flow of only energy across the boundary, while the mass still remains in the boundary. And a good example of a closed system is what? Is a piston cylinder combination with closed valve. When the two valve of your engine is closed, right? It is called a closed system, right? So the third one we're talking about will be an isolated system. The isolated what? Isolated system. Now, if you look at the word isolated, it means that what? Both energy and mass are not allowed to flow across the boundary, right? So it is a system in equilibrium. A system in what? In equilibrium doesn't have interaction with the surrounding. A good example is a flask, a thermo flask. If you notice in a thermo flask, sometimes it is coated inside. The vacuum inside is coated, and sometimes it is lagged by putting foam. There's no perfect isolated system, right? You can only slow the process, but you cannot stop the process. Is that taken? So an isolated system, energy and mass are not allowed to flow across the boundary. It's a system that has no interaction with its surrounding. So we'll look at another concept, which is called the thermodynamic property. Thermodynamic property, right? So we say that the property of a system is the observable characteristics of that system. And what are the properties that will be conversant with, that will be coming across? Properties like the mass is a property of the system. The temperature is a property of the system. The pressure is another property of the system. The volume is property of the system. Specific volume also is another property of the system. We have what is called the entropy, also is another property of the system, and so on and so forth. So this property of the system is divided into two. It's classified into two. We have what is called the intensive property, and what? The extensive property. So that are the two categories, classification of properties, right? Now the intensive property is the property that is independent of the magnitude of mass present in the system, right? It doesn't depend on the magnitude of mass present in the system. A good example of it is what is given as what? The specific, that is the volume, is a good example of what? The intensive property, right? And we have the temperature and what? Also the pressure. So the intensive property on its own here that you're seeing is always written in what? Small letter, right? It's always written in what? In small letter. Now we'll go into what is called the extensive property. The extensive property is a property of the system that is dependent on the magnitude of mass. So the intensive is independent, while the extensive is what? Is dependent on magnitude of mass, right? So for instance now, if I have if I have the volume in capital letter, since in the capital letter it is what? It is extensive property. It's given as what? The mass times what? The small specific volume. So the volume is equal to what? The mass times what? Small volume. So it means extensive property is equals to what? Intensive property times mass. Why intensive property is equals to what? Extensive property divided by what? By mass. So this is some of the little explanation on property. Right? We need to know the extensive property is always in capital letter and intensive property is always in what? In small letter. So sometimes when you hear per unit mass, you are talking about the intensive property. Now, we're looking at state of a system. Now, this is another terminology we hearing always when you're dealing with thermodynamics. Now, when you say state is the overall condition of the system at a given point in time. Right? That is the state. So what is the state of water at so the temperature? With state of water at 0 degree is said to be what? Solid. State of water at 100 degree is said to be what? Gas. And state of water at our normal room temperature is what? Is liquid. So the overall condition of the system at a given point in time. Now the next thing you should know is what we call a process. A process is said to be a system is said to undergo a process when it changes from one state to another. So when a system move from one state to another, it's said to be what? Process. Like when liquid water move to what? Solid water, which is your ice block, it says what? It has undergone a process. Or when liquid water evaporates into gas, it says it has undergone a process. It has undergone what? And that is what we call phase change. Right? So now another one we need to know again is what we call cycle. So we said that when a system undergoes series of processes, it's said to be what? A cycle, such that the initial state is identical to what? The final state. So if I'm to show you this on a table, probably I have something like this. This is my X property here. And this is my Y property here, right? So if I have this way, so let's assume that this is at this point here is state 1, here is state 2, this is 3, and this is what? 4. Now for states, we know that 1, 2, 3, 4, they are all states. This is state 1, state 2, state 3, and state 4. But for process, when you move from 1 to 2 is a process. When you move from 2 to 3 is another process. When you move from 3 to 4 is a process. And when you move from 4 to 1 is what? Is another process. Now, in terms of cycle, when you move from 1 to 2 to 3 to 4 back to 1, you see it has undergone a cycle. Now we say the initial is identical to what? The final state here. So I hope this video has been helpful to you. If you find it helpful, don't forget to click on the subscribe button. Thanks for watching.